Hello everyone, this is Space News for June 2020, brought to you by the Multimedia Learning Center at Frostburg State University. In this month, 2 stories about planet formation caught our attention in the news. The first one could be the first direct evidence of a baby planet being born. Planets form in disks of gas and dust as material collides, clumps together, and grows over time. Astronomers used one of the European Southern Observatory's very large telescopes to image AB Aurigae as follow-up to the detection of a protoplanetary disk. They made use of the new Spectropolarimetric High-Contrast Exoplanet Research Instrument, which can image extrasolar planets a little larger than Jupiter. AB Aurigae is in the constellation Auriga, the charioteer, near his left foot. This is a wide-field image of the region where AB Aurigae is located. The darker-looking area above and to the right of the bright blue stars near the center is a dense region of gas and dust from which stars can be born. The results show spiral structure in the gas and dust that make up the disk of AB Aurigae. Inside, the white circle near the middle of the image on the right is a twist in the spiral structure. That twist is predicted by theories of planetary formation. It allows gas and dust from the disk to accrete onto the forming planet and make it grow. The blue circle on the bottom right shows the size of the orbit of Neptune for perspective. What we may be seeing is the birth of a gas giant or an ice giant similar to Jupiter or Neptune. Our second story provides insight into the environments favorable for planet formation. It's about a young star cluster called Westerlin 2. In this image, you can see some of the surrounding parent cloud of gas colored orange. Astronomers used the Hubble Space Telescope to image Westerlin 2 over the course of 3 years. They found that the apparent brightness of some stars varied with time. This is predicted to happen due to dense clouds of dust, some of which could become the building blocks of planets. As the dense dust clouds orbit the star, they periodically block the light from the star. This is an example of what the data looks like. The star that is circled appears to change in apparent brightness. The dimming of the star is most apparent for these 2 times. What makes this interesting is that more stars are observed to vary in apparent brightness the further away from the center of the cluster. To explain this, the authors note that the center contains more massive stars than elsewhere in the cluster. These massive stars, as massive as 80 times the mass of the Sun, emit intense ultraviolet radiation and stellar winds that disperse the dust clouds around neighboring stars. This means that it may be more difficult to form planets in the central regions of young star clusters. That's Space News for June 2020. This is Dr. Jason Spates wishing everyone clear skies.